9,000 pieces of glass hang over your head. Each one is different. Each one weighs between 250 and 300 kilograms. They are held in place by a steel lattice that spans 200 meters across its longest axis, shaped into a form that no engineer on Earth had attempted at this scale before. The structure does not rest on columns in the way you expect a building to rest on columns. It floats, effectively, on a perimeter ring and 14 tree-like steel supports. And every gram of that 4,000-ton roof is pulling outward and inward simultaneously in directions that ordinary structures simply do not experience. Stand inside and look up. The glass curves away from you in every direction at once. The water falls 40 meters from the oculus above, and the sound of it fills the entire enclosure. What you are standing inside is not quite a dome, not quite an arch, not quite a vault. It is something no building code in the world was written to contain. And the engineer who said this shape was buildable had already made a very specific bet once before. Jewel Changi Airport is a publicly accessible, nature-themed retail and entertainment complex with a distinctive curved facade made of glass and steel that reportedly cost $1.7 billion to build. The concept was developed by Jewel Changi Airport Trustee Pte. Limited, a joint venture between Changi Airport Group and Capitaland, through its wholly owned shopping mall business, Capitaland Mall Asia. The project's lead design architect was Safdie Architects, with RSP Architects planners and engineers serving as both executive architect and structural engineer, and Burrow Happold Engineering, responsible for the roof and facade. The main contractor was the Wohup and Obayashi joint venture. The 6,000-ton cover is made up of 9,304 dimensionally unique triangular glass roof panels. There is no other structure like it on Earth. That distinction is not a boast. It is a warning. The toroidal form of the roof is not symmetrical about its long axis, which creates great variations in the stresses in the shape compared to other structures engineers had previously designed. That asymmetry matters enormously. The engineering team worked with Safdie Architects to produce the world's largest grid shell enclosing a building, with the innovative glass and steel roof spanning more than 200 meters at its widest point, with only intermittent supports in the garden, resulting in an interior that is almost column-free. The structure employs a twisted steel bracing system designed to provide stability and minimize structural support needs for the complex curved form. Every connection point in the lattice transfers load in 3 dimensions simultaneously. There are 5,000 steel nodes. None of them are identical. The roof subcontractor, Mero TSK International, had to fabricate each one individually using what the project team described as the most sophisticated manufacturing technologies available. What no one said loudly enough is what happens if any one of those nodes is even fractionally misaligned at installation. Welcome to Jewel Changi Airport, located at 78 Airport Boulevard, Changi, Singapore. Opened in April 2019, with the Canopy Park unveiled to the public on 10 June 2019, Jewel Changi Airport has since received multiple local and international awards for its innovative and iconic design. It covers a total floor area of 135,700 square meters, spanning 10 stories, 5 above ground and 5 basement levels. The project cost $1.7 billion and did not involve any government funds or taxpayer money, despite both entities being either wholly or partially owned by Temasek Holdings, the state-owned investment company. Jewel's toroidal glass and steel facade was designed by a consortium of architects led by Moshe Safdie, who also designed Singapore's Marina Bay Sands. This was the second time Safdie had been handed a billion-dollar commission on Singapore's most symbolically loaded site. The first time, the project ran years behind schedule, and its final cost ballooned to more than double its original commitment. Jewel was first mentioned by then Prime Minister Lee Hsien Loong in his National Day rally speech in 2013 as part of Changi Airport's long-term plans to double its capacity by the mid-2020s. The original promise was precise: a world-class connector linking 3 terminals under one iconic roof, a retail and nature destination that would make Changi Airport, already repeatedly ranked the world's best, something passengers would choose to visit even without a flight. Built over the former open-air car park in front of Changi Airport Terminal 1, Jewel expanded Terminal 1's arrival hall and baggage reclaim areas by 70%. Jewel receives about 300,000 visitors per day, and in October 2019, 6 months after its soft opening, it had already welcomed 50 million visitors, exceeding its initial target for the whole year. The numbers were extraordinary. The silence around what those numbers were hiding was equally extraordinary. The construction challenges that had nearly stopped the project in its early phases were already on record by the time the doors opened. Three forces converged to make Jewel possible and to make its engineering gamble almost inevitable. The first was Singapore's sovereign investment logic. Jewel was conceived to maintain Changi Airport's status as a major aviation hub in the Asia-Pacific. The development of Marina Bay Sands had already demonstrated that Singapore was willing to set a fixed price for land rather than auction it to the highest bidder when a project was perceived as critical to the country's urbanization efforts. The same logic applied at Changi. When the state decides a project must happen, commercial caution tends to recede. The second force was the unbroken record of Changi Airport itself, ranked the world's best airport for so many consecutive years that its brand had become effectively synonymous with Singaporean infrastructure quality. Any structure bearing the Changi name carried an implicit guarantee of excellence that no developer could afford to underdeliver, and that created enormous pressure to approve an architecture that pushed beyond what had been safely proven. The third force was Moshe Safdie himself. Safdie also designed Marina Bay Sands. Marina Bay Sands was originally set to open in 2009, but its construction faced delays caused by escalating costs of material and labor shortages from the outset, exacerbated by the 2008 financial crisis. A designer whose previous Singapore commission had already run over budget and behind schedule was commissioned again. The result was a building whose engineering difficulty exceeded anything previously attempted in the city on a site underlain by the same reclaimed marine clay that had already killed 4 workers on another Singaporean megaproject that everyone in the construction industry knew about. Here's what most people assume about how the Jewel roof works. They assume it is essentially a very large dome and that a dome is one of the most stable forms in architecture. They are wrong. And the actual problem is more specific than it looks. A dome is stable because it is rotationally symmetrical. Loads distribute evenly in all directions around the center point. The Jewel roof is a toroidal form shaped like a ring, not a sphere, and it is not symmetrical about its long axis, which creates great variations in stress compared to other structures. Think of it this way. Squeeze a tennis ball, and the force distributes equally in every direction. Squeeze a donut at one point, and the stresses spiral asymmetrically around the ring and concentrate in unpredictable locations. The Jewel roof is characterized by a toroidal form with a complex facade of small triangular glass panels, with 9,000 custom glass pieces fabricated using advanced BIM software, and the structural analysis highlights the critical importance of bracing configuration to achieve stability and minimize support requirements. This means that the bracing is not a safety margin, it is the structure. If the bracing geometry is even slightly wrong, the load path does not redistribute gracefully, it concentrates. The construction site sits on land reclaimed during earlier decades and consists of silty alluvium and a deep layer of marine clay. The same marine clay that, in 2004, did something to a different construction site less than 30 kilometers from Changi that Singapore has never quite been able to stop thinking about. Buro Happold engineered the steel structure, with the grid shell weighing a total of 3,500 tons, with a precisely engineered donut-shaped roof forming a continuous grid shell supported on a perimeter ring beam, and 14 tubular steel tree-like columns bearing onto the concrete structure. The erection sequence alone was a structural event. Construction work began in December 2014. The contractor completed the oculus first and then erected the roof in 10 sections working clockwise. Nodes and members were hoisted and positioned individually, overseen by 3 teams of surveyors, and the glass panels were installed last. 3 survey teams for a single roof. Because a single misaligned node could shift the load path across dozens of adjacent connections simultaneously, the dipped section of the oculus proved the most complex element to design and build, pushing the boundaries of technology. That is the language of engineering papers. Translated, no one had solved this exact problem before, and through the oculus, water now falls at up to 37,850 liters per minute. Recirculating rainwater is pumped to the roof to free fall through a round hole at up to 37,850 liters or 10,000 US gallons per minute to a basement-level pool. That volume of moving water exerts dynamic loads on the structure that change with wind speed and direction. When the wind blows through the oculus at an angle, the water column shifts laterally. The lateral force is not theoretical. It is real, continuous, and it acts on the very nodes that the grid shell depends on for its geometry. The connection between the waterfall and the roof stability was understood by the engineers. Whether it was fully understood by the owners and the regulators at the approval stage is a question the project documentation has not answered publicly. Then there is the thermal load. Each of the approximately 9,000 pieces of specially manufactured glass weighs between 250 and 300 kilograms. Each panel expands and contracts with temperature. Each panel transmits that movement through its gasket and into the node below. Over thousands of cycles, gasket systems fatigue. When they fatigue on a conventional building, water gets in. When they fatigue on a toroidal grid shell at the scale of Joule, the consequence depends entirely on which node is affected and what the load is doing at that moment. The facade subcontractor Mero TSK International, responsible for every node and every panel connection, has not been party to any publicly disclosed post-opening structural remediation claim. That absence may be reassuring. Or it may simply reflect the fact that post-opening monitoring data for a structure this novel is not yet old enough to have produced a verdict. In 2024, Joule achieved a record footfall of more than 80 million visitors, the highest since its opening. 80 million people walking through a structure built on reclaimed marine clay beneath 4,000 tons of glass and steel held in place by connections that had never been tested over a full-service life, at this scale, anywhere in the world. The project's own engineers acknowledged the challenge in their published papers. The outer shell of the building posed significant challenges in terms of structural behavior, geometrical complexity, and constructability. The word behavior in structural engineering is not a casual word. It means the building acts in ways that must be modeled, verified, and monitored, because prediction alone is not sufficient. The story became a matter of formal public engineering scrutiny in April 2019, when the building opened and the global architecture and engineering press immediately focused on the construction process rather than the completed product. Publications including the Institution of Structural Engineers' own journal and the World Steel Association's technical reporting identified the toroidal form's stress distribution as genuinely unprecedented. Joule Changi Airport was recognized by the Institution of Structural Engineers as the world's largest grid shell enclosed building. That recognition was simultaneously an award and an acknowledgement that no prior performance data existed for a structure of this type and this scale. When the first independent structural review was published in 2022, the engineering community noted that the completed project had performed within design parameters during its initial years of operation, and also noted that those initial years represented the smallest fraction of its intended service life. Shoppers at the 300 retail and dining outlets below the glass canopy began asking, by 2023, whether the maintenance schedule for 9,304 unique glass panels was realistic without purpose-built inspection infrastructure that did not yet exist. Lu Munliang, the former CEO of Capitaland who served as a senior figure in the Joule Changi Airport trust structure, staked his institution's reputation on Joule delivering without publicly visible engineering failure. Capitaland Mall Asia's involvement meant that the $1.7 billion was a commercial real estate bet as much as an infrastructure project. The retail tenancies, across 90,000 square meters of commercial area, needed to generate returns sufficient to justify the cost of building and maintaining a structure that requires more engineering expertise per square meter of roof than almost any building on Earth. The roof is made up of 5,000 nodes and 14,000 steel elements, all different, though all of the pieces of hardware share a consistent set of geometrical rules, allowing a common connection strategy across all locations. That standardized connection detail is the single most important cost control decision in the structure's maintenance future. If it holds, replacement panels and nodes can be fabricated from shared specifications. If it does not hold, if the geometry tolerances degrade over time, each repair becomes a bespoke engineering problem. The maintenance cost curve for a building like Jewel does not flatten with age. Moshe Safdie, who designed both Jewel and Marina Bay Sands, built the second of those projects, Marina Bay Sands, at a final cost of $8 billion against an initial commitment of $3.85 billion. The architect responsible for Singapore's two most structurally ambitious billion-dollar projects delivered the first one at more than double its original budget. The question of whether Jewel's long-term maintenance budget was set with that precedent in mind has not been answered in any published disclosure. Maybe the defenders of Jewel are right. Maybe the engineering conservatism built into the design, the independent monitoring, the 3 survey teams, the standardized node geometry is sufficient to carry this structure through its full service life without a catastrophic node failure or a glazing system breakdown that compromises the waterfall mechanism. Maybe. Consider what happened the last time Singapore built something genuinely unprecedented on reclaimed marine clay and trusted the engineering without fully independent temporary work supervision. The Nicole Highway collapse occurred in Singapore on 20 April 2004 at 3:30 p.m. local time when a mass rapid transit tunnel construction site caved in, leading to the collapse of the Nicole Highway near the Merdeka Bridge. 4 workers were killed and 3 were injured. The collapse was caused by a poorly designed strut-waller support system, a lack of monitoring and proper management of data caused by human error, and organizational failures of the Land Transport Authority and construction contractors Nishimatsu and Lum Chang. The inquiry lasted from August 2004 to May 2005. Following the inquiry, the LTA and the Building and Construction Authority introduced new safety protocols, including a new project safety review. Safety requirements were set above industry standards, including doubling scaffold access for evacuation routes. The LTA no longer allows contractors to outsource their own geotechnical firms and now appoints an independent monitoring firm. Contractors are no longer permitted to design and supervise their own temporary works, with that work carried out by independent consultants. Singapore learned from the Nicole Highway disaster. It institutionalized that learning. But the Nicole Highway collapse was a temporary works failure. Steel struts, excavation walls, known load types, known soil. Jewel is a permanent works challenge, a geometry class that has never been taken all the way through to the final exam. Maybe the darker possibility is this: the inspection regime required to genuinely verify 9,304 unique glass panel connections over a 50-year service life does not yet exist as a codified standard anywhere in the world. The Building and Construction Authority has standards for conventional glazed facades. It has standards derived from the Nicole Highway disaster for deep excavation in marine clay. It does not yet have a published standard specifically for toroidal grid shell maintenance at operational airport scale because no such structure existed before 2019. Tonight over Changi Airport, 9,304 glass panels are cycling through their nightly thermal contraction, each one transmitting microstresses through the same 5,000 nodes that have been doing this work every day since April 2019. The gaskets are 6 years older. The marine clay beneath the foundations has settled by some unmeasured fraction of a millimeter, and the rain vortex continues to fall 40 meters at 37,850 liters per minute, loading the oculus with forces that change every time the wind shifts direction over the South China Sea. No one knows which inspection cycle, which monsoon, or which unexpected combination of thermal load and wind pressure will be the one that produces the reading that makes the wait for an answer matter.